Hi, everybody. So a question from my friend Don Carter. Everybody. So a question from my friend Don Carter from the conservation community about my method of couching and transferring then the pulp from the mold to the comic was about how do I know the thickness of the pulp. So the math involved is going to be the topic of this, and it's going to be entirely hypothetical, and I haven't really applied it yet, 100%, I should say. I have dabbled with it, but I haven't really had much success in getting the exact consistency of the sheet done until I started using Formation Aid, right? Formation Aid gave me that consistent sheet that now can be the same height, right? So I had, for me to get this done, first thing I had to do is determine the height of, the thickness of a comic book wrap. And if you have a micrometer, that's the way to go to measure the height of a wrap or the thickness of a wrap with a micrometer. But if you don't have one, then what do? Then in my case, I ended up measuring a stack of them and getting an average height of a per wrap is going to be 0.12 millimeters is what I got, right? And again, we're doing here hypothetical. Second thing I had to determine is the area of a wrap and the area of the mold, right? So the mold I'm using, let's do the mold first. The mold I'm using is 5 inches by 7 inches, except that the area that takes the mold is less than that, right? So it is in centimeters, width is 10.2 centimeters, and my height is, not my height, but the mold's height is, sorry, no, I was saying height, I mean length. The length is 15.5 centimeters. So the area of the mold, I'm going to call it A1, is going to be 10.2 times 15.5, and that's going to give you 158.1 centimeters squared. That's the area of the mold itself. Okay. Third thing I did is I calculated the area of the wrap, and the area of the wrap is about 34 centimeters width by height is 26. That's something you can measure, and that gives you an area of the wrap to be 884 centimeters squared, right? So we have this information already there. And the other thing I wanted to find out is the weight of a book. The weight of the book, this way I can figure out the weight of a wrap. You can weigh a wrap, certainly, the wrap you're working on, but I weigh the book itself. So if you weigh the book, it's an Archie book, so it weighed about 43 and fractions. So the Archie book I'm working on weighed 43 grams, meaning that per wrap, each wrap is going to weigh 43 divided by 9, and that's again an average because the cover is going to weigh more than the interior, interior wraps most likely. So 43 divided by 9 is going to give you 4.8 grams is the weight of each wrap. So the wrap I'm working with is 4.8 grams, has an area of 884 centimeters squared. The mold, I know the area of the mold, and now I've got to figure out the weight of the pulp to add to achieve a height of 0.12 millimeters. So if you're following, let me get another thing to write on here. So now I have some info here to figure out how much pulp to prepare to go into the mold so that the area I'm filling of the mold, the 158.1, will contain enough pulp to give me a wrap that is going to end up being 0.12 millimeters in height. All right, so I have the information. I have already 4.8 grams. 4.8 grams is the amount of pulp needed to make a wrap from the comic, right? Which is 884 centimeters squared. And the mold has an area of 158.1 centimeters squared. And we need to figure out how many grams of pulp it takes to fill this area that gives us ultimately a wrap, paper with the height of 0.12. So X is going to be 158.1 multiplied by 4.8 and divided by 884. And that gives you about 0.86 grams of pulp. So I take 0.86 grams of pulp and put it into 100 mils of water, and then pour the whole thing into this mold, like in this area, and then even it out the thickness, provided that the pulp behave itself in the same amount everywhere. You should have a thickness of 0.12 millimeters. All right, so I'm not going to make 0.86 grams. What am I going to make? I'm going to make more than that. So if I take 6 grams of abaca, which is like multiplying this by 7 gives you 6 grams, and put that into 700 mils of water, right? So it's 0.86 per 100 or 6 per 700, right? And if you do that, then blend it, that will give me a final concentration of 0.86 grams per 100 mil that is put through the mold. Right, the problem in the past has been that pouring the stuff into the mold, it gives you an uneven sheet, right? You get a sheet. I don't have one too good here to show you, but I'll show you this one here, which is, right? You can see that parts are thick, parts are thin, very thin, and it's not a good sheet at all. Whereas if you use formation aid, you will get a far better sheet, right? This is with formation aid, these are without formation aid. You can see the difference. Right, so when you make something with formation aid, you get consistently the same thickness everywhere and the same density of the pulp everywhere. You get these even sheets, and you even get these nice little fibers extending from the edges, which are just like the tengujo, the Japan tissue fibers, right? So if I take, essentially, this is not the right amount here, but if I take, say, 6 grams of abaca and I put it into water, and say I have 250 mils of water here, I let it sit overnight in the water. The next day I can blend it. And after blending it, bring the water volume up all the way to 700 mils. And that will give you the 0.86 grams per 100 mil. And all you do then is you add your function and process aids. So what I mean by that, I mean like you add the sizing and you add the, if you want to diet, you can diet, and you can add the retention aids, and you can add the formation aids. Formation aid is the one that is going to give you those consistent sheets. So by adding the formation aid, the polyethylene oxide, you're going to get really nice consistent sheets. So you end up pouring 100 mils here and you wiggle it into the area until you get that sheet that is consistently thick, right? Has the same thickness of everywhere and the same even distribution of the fibers everywhere, which is really important, right? Like you can see here, you have even distribution of the fibers on this one, not on this one. This one is like lumpy in some areas, thick in some areas, thin in some areas. So formation aid does work, actually, does give you that nice finish at the end. So once you get the fibers distributed well within the mold, right, you're going to couch it, right, on a piece of cloth. It'll be wet and viscous and lumpy everywhere. You're going to put another sheet of cloth on top. You're going to roll it once, and that removes a lot of the water. And that is actually problematic, because when you remove the water, you need water for hydrogen bonding. If you're removing the water, then hydrogen bonding is going to be weak. And that's something was pretty obvious to me early on, is that how would you, so say you have here a small piece to fill, right? Say you have a small piece to fill. How would you fill it, right? So I can take, so pretend this is the mold, right? And I did the couching and everything. And I take now the piece I want, and I want to put it here, right? Let's say I take a piece from here. How do I fit it here, right? You can fit it in this way. You want some of the pulp fibers extending out to match with the rest, to be over the wrap itself, right? Problem is now this is a bit, doesn't have enough water. It has been rolled once. So how do I get it to bond here best, right? Well, the best way to do it, in my opinion, and I have to try it, right, is to get everything wet again. So get this wet around here before you place this on. Once you place this on, wet this again. Wet this, right? Wet it again. Make sure it's nice and wet. And then when you roll it now, I think stronger adhesions will occur. And if you can fray it even on the ends, if you can do that, fray the edges, that will give you better attachment tentacles, if you will, with the wrap, and will give you a better adhesion altogether, right? And if this doesn't work, again, it's experimental. If this doesn't work, then what? Then we can always still use it, right? Because this is one way of making these consistent sheets for small areas. Is we can, not the only way, I mean, we can probably do other math to figure out how much pulp you need here and all that, but it's a good way of introducing it in one swoop, because you're not dealing now with trying to figure out how much here and how much here with this, right? But I think the best way to do this is to add the couched pulp once after you roll it, right? And wet it. And if there is a need, you could always add a little bit of pulp, regular pulp with this, just around it, just to support it, right? If there is a need, if it doesn't work, you can always use methyl cellulose or starch around here before you apply the patch, right? I think that works. I think that will work at the end. So overall, I hope I answered Don's question. And this is one way to do it if you start from scratch. But say you have a certain amount of pulp already and you know how much pulp there is percentage-wise, then how do you figure out how much of that to add to a specific area or how much of it to pour into the mold, right? So that's another angle of calculating the amount of pulp you need to add to the mold. And we'll leave that for some other video. But I hope this was clear. I think I mumbled towards the end, but I think hopefully this is helpful for you guys and shows you the process of calculating the amount of pulp needed to get these sheets to be the same height as your comic book wrap, right? All right, thank you for watching, everyone.